Could you solve this without punching it into the calculator? Because the calculator might not even give you an answer because these numbers are so big. And if you are doing this in an Olympiad, you wouldn't be allowed to use a calculator anyway. So can you do this? Can you solve this by hand? Because there is an interesting approach for this type of question where you're dealing with big numbers and powers rather than punching the numbers in. What we can do here is to actually convert this calculation into algebra. Sounds weird because you're like, well, why would we want to do that? But actually, it makes this kind of simplification process a lot simpler. So if we let x equal 2015, then this whole thing just rearranges into x plus 1 cubed plus x cubed divided by x plus 1 squared minus x squared. Now, I'm sure you will be able to see that the denominator of the fraction is a difference of squares. So we can easily simplify that part. But what about the numerator? You may have come across the factorisation for the sum of cubes. So you may know that x cubed plus y cubed is equal to x plus y times x squared minus xy plus y squared. And you can double check that if you want to expand these brackets. X plus y times x squared minus x plus y squared will give us x cubed plus y cubed. Now, in our situation, we've got something slightly different because we've got an x, but also we've got x plus 1. But we're still going to want to factorize this numerator using this formula. So we can do that. And what does it simplify to? So we get x plus 1 plus x is our first bracket. And our second bracket is going to be x plus 1 squared minus x times x plus 1 plus x squared. And factorizing the denominator with the difference of two squares, we're going to get x plus 1 plus x times x plus 1 minus x. That's pretty nice because that just cancels to make 1. And we notice here we've got 2x plus 1 on the denominator. So those are going to just cancel as well, which is pretty neat. So the only simplification then we have to do is now this part. So we're going to get x squared plus 2x plus 1 from the first bracket, minus x squared minus x from our second term, and plus x squared, that stays the same. And collect the like terms, cancel. So this is just going to be x squared plus x plus 1. And now we have the easier calculation. Rather than cubing 2016 and 2050, we can just square 2015, which I believe gives us 4,060,225. And then we're adding 2015 and adding 1 to adding 2016. You get 4,062,241. And that is our final answer. So the technique here that is worth remembering, if you have this huge calculation that's going to take us ages to do by hand, see if there's a way to rearrange or manipulate it using potentially your algebraic skills to get something simpler that you can then figure out more easily. If you like this and you want to remember it, then save it. And if you know a friend who likes maths, who's going to be interested in this, then send it to them.